We're going to be starting the fourth section of the year, which is going to talk about prime numbers. And our goal by the end of this section is to be able to take a number and to break it down into only its prime numbers. But before we do that, we need to review what the definitions of prime and composite mean. A prime number is a number, and I'm going to put up here a positive whole number that has only one pair of factors. So if we think about numbers that only have one pair of factors, the number 5 jumps out at me. 5, the only pair of factors is 1 times 5. There is no other pair of whole number factors that can make 5. Another example would be the number 11. The only way to find a pair of factors is 1 times 11, not times 10. Another example would be the number 17. The only pair of factors would be 1 times 17. Now, a composite is the opposite of prime. A composite number is a positive whole number with more than one pair of factors. And this is important to remember because when we're talking about prime factorization, which is the goal at the end of this unit, we need to have numbers that are prime. So an example of a number that's not prime would be 8. 8 can be made by 1 times 8, but also 2 times 4. Therefore, the number is composite. Another number would be the number 34. It can be made of 1 times 34, also 2 times 17. Okay? So when we're thinking about prime numbers, they have to have one pair of factors, 1 and itself. So let's find all the factor pairs of each of these numbers. Let's start with 26. Now, the first pair of factors that's usually pretty easy to find is 1 times itself. That every number has 1 times itself as a pair of factors. Now, the number 26 is even, therefore we can break it down into 2 times, and then 26 divided by 2 would be 13. Therefore, we have 2 pairs of factors. This is not divisible by 3, not divisible by 4, not 5, not 6, not 7. And so the only 2 pairs are right here. You could write all of the factors by writing like this, or you could write it like we did over here. 36 is going to have a few more pairs of factors. So let's do 1 times 36 as our first pair of factors. 2 times 18 would be another pair. Then we have 3 times 12 and 6 times 6. Once you have the pair that's very close together or equal together, you know you should be done. So that is all of the factors of 36. Once again, we could write them in a line like we did before. Notice I do not rewrite the 6. And there is all of the factors of the number 36. So the next one is going to be prime factorization. And what prime factorization means is you want to take only prime numbers and you want to multiply them together to get the number that you started with. The way we do this is we call this the factor tree. You'll hear me talk about a factor tree all the time. If you bring me the words factor tree into class, you can get 5 SPs or 1 piece of small candy. Now, to do the factor tree, we can pick any pair of factors that equal 40. Now, there are a lot of options here. We could do 2 times 20. We could do 4 times 10. We could do 5 times 8. And what you know is that it does not matter what pair you pick first. I'm going to pick 4 times 10, but I could have picked any two numbers. Now, what we have to ask ourselves, are these prime? If the number is prime, we circle it and we're done. Well, 4 is not a prime number, so we can break it up further into 2 times 2. Now, we do not want to ever do 1 times anything because 1 is not a prime number, which you should know from the sieve of Eratosthenes activity. If you're unsure why 1 is not prime, make sure you come and talk to me. But we do know that these numbers down here are prime, so we are going to circle them, which means we're done. Once a number is circled on our tree, we are done. The number 10 is not prime, so I'm going to break this up into 5 times 2. 5 is prime. 2 is also prime, so we are done with the tree. Every number has been circled. So when we do prime factorization, you always write it in this form. 40 is equal to, and we're going to multiply all of these numbers times each other. I'm going to go 2 times 2 times 2 times 5. And you can write this in any order. It does not matter. And we know that this works because we can re-multiply out our problem. This is 4. 4 times 2 is 8. 8 times 5 is 40. All of these numbers are prime. Therefore, this is the prime factorization. So every number is prime. It multiplies out to get the number that we started with. We're going to do one more problem here. Once again, we are doing the prime factorization. So we want to do the factor tree, just like we did in the last problem. Now, this time I'm going to do a little bit different strategy. When this number is even, I like to just pick the number 2 right away. Well, 2 times 24 is equal to 48. Therefore, the number 2 can be circled right away. And now I break up the number 24. Still even, so I can do 2 times 12 this time. 2 is a prime number, so I can break up 12. Still even, we could do 2 times 6. The number 2 can be broken up, or is prime, but the number 6 can be broken up into 2 times 3. Each of these numbers are prime. So this is another strategy of the tree, but once again, if I picked, let's say, 4 times 12, I'm still going to get the same answer. So the first two numbers, as long as they're correct, it's still going to work. But I'm going to do 2 times 2 times 2 times 2 times 3. And if I did this right, this should equal 48. So this is 4 times 2 is 8 times 2 is 16, and 16 times 3 is 48. Therefore, we are correct. This is the prime factorization. All of these numbers are prime, and they equal our target number of 48. As always, if you have any questions, please let me know. Also, let me know what score you got on the video.